Hello, friends and followers. Well, here's an Amperex 7854 tube that I bought. Two of these from RF Parts. I paid way too much for them, but whatever, they're brand new tubes. Anyway, it's kind of a weird looking tube because it has two plate connections. It's really two tubes in one. And this thing will run off 12 volts, so yeah, heater voltage, max 13.8. Probably a little too high here. Let's see, let's bring it down. There we go. Anyway, I've been running this tube here a bit, just getting to know it basically, and it's a hot little devil. I put some power into the tube here on the heaters, figured the pin out, and it's running. Heating at least anyway, which is what tubes do. This tube is built like an animal though. It has really hot, really thick plates on it. So that's what you want with a final tube. So we'll see how it goes. It's not quite, what is it, a tetrode? I think it's not a pentode, it's a tetrode or something. So it's gonna be a little different power amplifier in AB1 mode, but I'll try and make it work. So the other thing is it fits in the SWAN. It's pretty much the same height. It's a little shorter than the 8950 tubes, but of interest in the data sheet here, and I don't know, I just kind of found this thing and grabbed two of these, but it'll dissipate each anode, which is a plate, will dissipate 30 watts. The 3950, I think, or the 8950 will dissipate, I think, 34 watts. So this is pretty good because I have two anodes, so that's about 60 watts. So one of these tubes should pretty much do the job of two of the 8950s, and I'm going to put two of these tubes into the SWAN 700. So that should give me some headroom, I'm hoping, if I can figure out how to connect these up. And they're saying this thing will do up to 175 megahertz. So that is probably a much better rating than a sleep tube has. So I'm not sure what these are built for, microwave or something, I'm not sure what, but they seem like they're pretty hardy tubes. So, and I got a brand new tube here. So I've bought the socket. It hasn't come in yet, the Johnson socket. I found a couple of those on eBay. So yeah, I might try and stuff these into a SWAN 700, just as an exotic attempt to get it running. And well, because I'm tired of buying sleep tubes, getting ripped off by people, getting sleep tubes that are used, and they say they're new, and yeah. So, okay, anyway, let's look at some voltages here. So, I wish this thing wouldn't do this. View, it always goes to 2 pages. It's like, why does it does it think I want 2 pages? Okay, so frequency 175 max, that's way up there for an HF transmitter. DC2 grid voltage, it'll take 1,000 volts on a grid, that's crazy. DC grid number 1 will take 300 volts. Plate current, that's pretty good, I guess. 240 milliamperes, I guess it isn't that much really. Plate dissipation, oh, it's grid dissipation, that's a lot for a grid. Okay, the plate, yeah, 34 watts times 2 plate input. Okay, it's going to be 2 times 120, about 240. Okay, so anyway, let's look at the operation here. DC plate voltage is going to be 1,000 volts. So my power supply is shooting out about 952 volts, 952 volts. So it's right in the limits, but it beats the 6146 tubes I had. That's the plate voltage, grid voltage. Yeah, the grid's about, yikes. Grid might be, I don't know, 380. I might have to crank the grid down. Anyway, there's my plate, milliamperes, so 240. If I have 2 of these tubes, that's 240. That's going to be 480 mils. That might be just right. If I can pull this off. Driving power is going to be 3.5 watts. I'm not sure what driving power that 12BH7 can provide. Anyway, power output 163 watts. What does that mean, power output? Power output? They're talking input here? Maybe that's right. So with 2 of these, I might get what? 350 watts? I guess I'd be happy. Yeah, I'd be happy with that. The efficiency, 68%. That's pretty good. That's pretty damn good. All right, so that's push-pull. I'm not gonna do push-pull though. And this thing is forced air cooling too. Heat sink operation. Well, I'm gonna do forced air. And let's see, what else we got here? Heat sink operation. I'll probably melt the tube. Anyway, there's the connections for it. There's all that jazz. Plate current, volts, how many amps it'll pull at a certain grid. I guess I can compare that up to the 8950 and see what stacks up. All right, so that's about it. You've all seen these charts before. Constant current. I don't think I'll be giving it constant current, but that's how it loads up. Anyway, this will be an interesting experiment. I hope I can pull this off without wasting too much time doing it. With the 7854, it does fit into the SWAN barely, as far as width-wise. So yeah, I think I'll get them in there. The trouble's going to be getting the sockets in there, but the tube itself will fit if I can get the socket mounted correctly. So anyway, yeah, this thing's been cooking away here. It's probably really hot now to even touch it. But anyway, let me find some pliers here. So yeah, there it is running away there. I'll show you what I mean as far as it fitting. Let's turn it off. And disconnect it. I guess I'm just gonna pull it above, let it disconnect itself. There, and carry it over, it's hot. To the SWAN. Turn some lights on in this house here. Lights on, there we go. So it'll fit in here just fine. So the way this thing works is it has like a little sunken area. And if you drop this in here, you can see where it fits. Not the socket, of course. I'll take those sockets. I'll take the whole board off the bottom, but I just wanted to make sure it fit in here width-wise. As you can see, it, let's take this out of the way. It has to manage the width here that they've given us in the SWAN. You can see it's going to hit there and hit there, but if you look at the circumference of the tube, the diameter of it, the width, it fits on that side. It fits there too, so it'll slip down in there. I'm going to have to get the socket in there aligned just right. Whoa, just right, but yeah, 2 of these will fit right in here, so that's what I'm going to do. I'll just cross the top of those plates and hope for the best. Anyway, this is my middle finger to the eBay sellers selling sleep tubes for 120 bucks. Middle finger to you people. Plus I get a brand new tube here with better ratings, so that's how it is. We'll see if this thing will come back to life. This one had a lot of harmonics with the old tubes. A lot of crap coming out of it, so Yeah, I did buy a spectrum analyzer to try and analyze this thing when I got it running. So the spectrum analyzer that I bought isn't in great shape. I guess I can show you that. That is here on the floor. I paid about $150 for this thing, and it's not in great shape. I'm going to put it into this scope here. This is a 7803 tech scope. This thing is a bear to get in here, and I think people have tried to shove this thing into the scope. This will go into a larger 4-bay scope or this 3-bay, and the problem is people will shove this thing in and the guides get broken. So these guides here, I bought this thing with broken guides. You can see it's all broken there. This one's broken too, I think, at the other end or something. So I told the guy I wanted some money back, and he was kind of snotty with me. He's like, well, nice try. He did give me a discount when I bought this thing from his listing price, but this is fine. I can live with that, I guess. But the problem with this analyzer is the frequency selection is broken. So if you look at this control on the front of it for the frequency, when you use this thing, you want to set this thing to the frequency in megahertz. So that's the megahertz, 13.5, and when you turn this, it grinds and skips, so it jams. So it's way out of calibration. This was made in the 70s, I think, and it sticks, so I gotta take this apart and fix it if I can, and there's no way I'll get parts for this thing. Plus this little button here is all bent up too. I don't care about the button, I care that this thing works. So it's ingenious how they made this thing. A little thing flips out, but I don't want to spin it hard because it's all screwed up. It'll just grind and destroy what's left of it. So anyway, this is what I plan to use to look at the output of that transmitter. Look at the spectrum of it. This is a pretty cool device when it works. So this one needs some work. I thought about sending it back to the guy because it's hard to get one of these that works at all, but I guess I can live with the cracks. I don't like that the guy didn't disclose this thing had cracks in the back of it. He didn't disclose this thing was a mess either. He just sold it as parts only. But what are you gonna do? It's old stuff, old Tektronix stuff. The scope will fire up. I think I paid 20 bucks for the scope at the local SWAN meet. I stuck it on eBay for sale, but the more I think about the scope, I shouldn't sell it. Let's see if I can make it go for you here. Put these back in carefully. Just give it a little push. And give that one a push. Okay, that clicked in. Did that click in? Looks like it did. Yep. Whoa, clicked in. And then if this scope is plugged in, you pull the knob here and it comes on. Like that. And you'll see the screen light up with indications. That's a happy scope or not. Nothing so far. There it goes. So it seems like it's working. Depending which one was selected here. And this one's selected. Or you can select them both. Anyway, it's a nice little scope. Probably from the 70s. And is this module working? It's not lighting up. Is it plugged in all the way? Probably not. Turn it off. It seems like it's in there. Looks like it's sticking out though. Come on. Don't want to force this thing. And it should just clunk in there, right? Unless I broke it trying to get the other thing in. It doesn't look like it's in. No, it's not in, is it? Clunk. There, now it's in. Son of a gun. You just don't want to force these things. You'll break them. So yeah, I'm not sure if it boots up and one of these is out. It's gonna carry. This horizontal has to be in. Okay, now it's going. So you can see now we have control the sweep. Now it's a matter of can we get the sweep running. Let's see, I think this one's the sweep here. No, there it is, beam finder, there's the beam. It's probably gotta do trigger or something on here to get the go. Let's see, positions, mode. I don't use this scope a lot, so I haven't used it for traditional beam scope. We have to get the mode right. We're on right now, left. Let's see, left. Oh, there it started going. Left and right. Okay, right is this guy here. We're on chop. Okay, I see the beam. It's just kind of down there a ways. I can see it down there, hitting the bottom. I'm not sure what channel we're on, but the beam is like over to the side or something. Let's see, horizontal. Where's horizontal? Horizontal's up here, is it? There should be a horizontal somewhere on this thing. I don't want to cook it. There. So the beam is like way off on the side. And there should be a, okay, fine position. Okay, this must be the position here. Let's give it some gas. Wrong. Wrong. It seems like the beam is, there it is. Yeah, it was way off to the side there. Anyway, I don't know the scope very well yet. I don't use it enough. But it sure is dandy, isn't it? Slow it down. Speed it up. So that's your horizontal, and then of course your vertical. You can fiddle with these and get more microvolts. I want to get my friend Dave a scope. I want him to have a scope. Dave in New Jersey, you need a scope for debugging radios. All right, anyway, that's my little demo of the scope. The spectrum analyzer, you're gonna pull these out and jam it in there. It's not easy to get it in there. It breaks things. I'm not sure why the alignment's all messed up, but I know from the guides on back of the spectrum analyzer, the guides being all corrupted isn't helping the situation. And I think people just jam these in there and break things. So anyway, it is an instrument. It does take due care to work with these. You can't just be throwing them in just because it's 1970, 80, 90. Just because it's 55 years old doesn't mean it doesn't deserve the same respect it had back when it cost $10,000, $20,000 in 1970. Who spent that money? Who even had that kind of money to procure this stuff? Some corporations, man, they got all the money. All right, thanks for watching. Have a great day.